Hey folks, how's it going? Mr. Moray here, coming to you with a video to accompany the degrees and radians investigation. Okay, this was for 4/28/2020. Okay, this video is meant to guide you along as you do it, but again, the focus is really on getting you to explore and find new stuff. Okay, so what you see here is this is the do now for today. Okay, and this activity is meant to get us warmed up and thinking about it. We talked about this in the Google Hangout last Wednesday, or I guess the last Wednesday we had school, so 2 Wednesdays ago. So what I'm going to do is I put this again as a do now today. I'm going to go ahead and link right now. You're going to see it come up. I'm going to put a link to the do now for today so you can watch me work through this if you haven't yet done it. But the idea is this. Okay, we're going to talk about this new way of measuring circles. So it used to be that we talked about this idea of a degree. And we said a degree is a measurement of an angle. And what we do is we take our circles, we cut it up into 360 pieces, and each one of those pieces we define to be a degree. So if I have an angle sitting out there in the wild and it's a 37-degree angle, it's 37 of those circle pieces. Okay. So you're saying, right, if I cut my triangle into 360 pieces, right, here Hadley has 120 of those pieces. So I can see, okay, she's got a third of the pie. Avery has 45 of those. So I could see she had an eighth of the pie. But 360 seems, I don't know how to say, maybe arbitrary. Why 360? What's the significance of that number? Right? And if we think about it, a lot of the times angles aren't part of circles. Right? This is the first time that we've really seen this happening, right? This angle being inside of a circle. We've mostly seen them coming up in triangles, coming up just kind of hanging out there in the wild. So we need another way to understand measurement of angles. Okay? And so what we have is we have a radian. And a radian is another way of measuring an angle instead of degrees. Okay? Now, a radian is technically what we call unitless. Doesn't have a specific unit, but we could talk about this. We could talk about, for example, meters and feet. Meters and feet are two ways of measuring distance. Now, meters, many people prefer because they're in steps of 10. Right? People talk about the 100-meter dash, the 200-meter dash, right? The 4x100 relay, if you're a running or track fan, right? They're always those nice whole numbers. Whereas with miles, yeah, we talk about miles, but it's not really the same, right? The numbers aren't as clean. Okay? So similarly, we could talk about an angle in terms of a radian, and we could talk about an angle in terms of a degree. So here's what we're going to start by doing. Please head to the website whs.willnot.fail. It's going to take you to a willnot.fail website that accompanies today's lesson. You want to click on the investigation, that first link, not to the handout, but the first link, the first Geogebra sketch about discovering radians. And what you'll see is this sketch come up. So what I want you to do in this sketch is I want you to go ahead and I want you to play with these sliders. So this slider will make the angle ACB larger or smaller. And this will make the radius larger or smaller. Due to constraints around the size and being able to have everything work out nice with code and etc., I've kept the radius to 1 or 2 because I want us to focus on these questions. When the radius is equal to 1, like you see here, what do you notice about the radius and the arc length? When the radians equals 1. So okay, so get your angle to be equal to 1. Okay? So when radians equals 1, what do you notice about the radius and the arc length? How many radians will we get when this is equal to 180? What about 360? So slide the angle around and try to figure that out. Then, how could you figure out the arc length based on the number of radians? Remember, with degrees, we take the total number, we take the degrees, the corresponding degrees, and we divide them by 360. How could you do something like this with radians? Okay, and finally, see if you can click on the enable sector box, and you can see the sector area will come up. How do you think we could figure out a formula for this sector's area? Okay, so what I want you to do, pause the video, go to the whs.willnot.fail, play around with these, okay, and then when you're ready, unpause, and I'll show you some of my ideas here. All right, so yeah, I came back and just want to make sure I gave you a little look at what the things actually look like here. Don't worry about the 4/26/2019. I had just done this lesson as well in the past, so I had this floating from a previous year. So don't worry too much about the date, because it actually is 4/28/2020, right? Well, at least as of when we're doing this activity. So remember, what you're doing is you're clicking on the Geogebra Sketch 1, what are radians? Okay, and I wanted to also show you this because it's a little bit nicer how things come up. So I'm going to slide this over, see if I can make this go away. There we go. So the radians comes up. So when radians equals 1, what do you notice about the arc length and the radius? What you should notice is that they're the same. And that's how a radian is defined. 1 radian is defined such that the length of the arc, what we call the intercepted arc. Okay, so you can imagine these and this is like an arc. So when the measurement of this arc is exactly equal to the measurement of the radius, then the angle, okay, is equal in measure, it's equal to 1 radian. That's the definition of a radian there, okay? Now, how many radians are equivalent to 180 degrees? So if I was going to make this 180 degrees, notice that it's between 3.1 and 3.2. Right? Now, what famous number is between 3.1 and 3.2? Okay, if we look at 360, it's between 6.2-ish. Maybe 6.2 and 6.3. Tough to say. Right? 6.3, we're wrapped around 6.2. So there's another number that's between 6.2. Interesting. I wonder what that could be. All right. Lastly, the sector area and the arc length. So notice, well, right now the radius is 1. So that means that the arc length is equal to 2 pi. Because it's equal to 2 pi r, right? So now, think about it like this. Notice that this radians, whatever, is half of the total radians. And notice the sector area, the arc length, okay, right? Now, remember, we know the arc length, okay? Now we know the total circumference is 2 pi. Notice that 1 pi is about 3.1. So, interestingly, if this represents half the radians, the total radians, then the corresponding arc length is half the total arc length. Now, similarly, this is equal to pi r squared, right? So if I do the area is equal to pi, essentially, right? 3.1 to 3.2. Notice how this is equal to 1.6, about a half of the total area. So what it looks like to me is that if we can figure out how these radians work, then what we're going to notice is that there's a lot of similarity between how we do stuff with degrees and how we do stuff with radians. All right, so then let's snap back really quick. Let's snap back to this sheet where we got to come up with some answers here. So when the radians equals 1, recall, what did we know about the arc length and the radius? Right? We know they are the same. Okay, how many radians are there in 180? So we know it's a number between 3.1 to 3.2. And this is 6.1 or 6.2, I believe, to 6.3. Now, what famous number do we know about circles that's between 3.1 and 3.2? Maybe you guessed it is pi. And 6.2 to 6.3, that's like 2 pi. Okay? Now, how do we figure out the arc length based on the number of radians? Well, we could take the radians. Maybe we could divide by 2 pi, which is the same as 360, and then multiply it by the circumference. And it turns out we can do the same thing with area. We take the radians of the angle, we divide them by the total, and we multiply them by A. Because we know that 2 pi is the same as 360, and this is whatever your angle measurement is, right? So just like we did x over 360, now we're doing whatever our radians is over 2 pi. So those ideas really extend. Okay? And so just like, and I asked someone this recently, like, oh, right, in chemistry, aren't you guys doing dimensional analysis, right? Or haven't you done that? And exactly, you have, right? You've done a lot of that this year, right? You converted from, molecules to moles. You converted from like moles to grams. You converted for all different types of conversions. So we are going to do the same thing, right? And so just like there are 6.02 times 10 to the 23rd, all right, molecules in a mole, right? Just like there are 16 ounces in a pound, okay? Just like there are 2.2 pounds in a kilogram, okay? Just like there are 92 times 10 to the, I believe, 6 miles in an astronomical unit, 96 million miles, okay? There are 180 degrees in pi radians, okay? That's the magic conversion, 180 over pi. So if I want to convert from degrees to radians, so let me give you an example. Let's say that I say to you, I want you to convert an hour into seconds. So you take an hour and you multiply it, right? But you don't put your hours up here. You want your hours to cancel out. You want to end with seconds. So you multiply by 1 hour and you put your 60 minutes up here because there's 60 minutes in an hour, but it's the hours you want to cancel out. Then, right, you do your 60 seconds per 1 minute because you want the minutes to cancel, right? So then you're left with seconds. So similarly, you want the degrees to cancel, right? Because you want to get 2 radians. So what I do is I take my pi and I put it over 180 degrees. And that way the degrees cancel out and I'm left with pi. You should have pi in your answer if your answer has radians, okay? Now, what I'm going to do is I'm going to now try to simplify this. So these both have a 2 in them. So that's 110 over 90. They both have a 10 in them. So it's 11 over 9. And I'm done. I'm done. I can't go further than that. So it's 11 over 9 pi. All right. I'm going to do another one. So we're going to do negative 80. And when it's a negative, it's all right. You just get a negative times 180 over pi. Now, did I do that right? No, I did that wrong. What was my mistake? My mistake was that I had things flipped around here with regard to the conversion factor. So notice degrees and degrees, you don't want that. What you want is you need to have degrees down on the bottom so the degrees cancel out. You get pi on top. And now you simplify. This becomes negative 40. This becomes a 90. This becomes a negative 4. This becomes a 9. So it's negative 4 pi over 9 or negative 4 over 9 pi. All right, here's what I want you to do. I want you to take a minute. I want you to pause the video. I want you to try to figure out the next two, okay? And then when you're ready, unpause, and I'll show you how I got them. Okay, so here again, you want to multiply by pi over 180. Okay, so here they're divisible by 9. This is 4. This is 20. This is 2. This is 10. This is 1. This is 5. So it's 1 pi over 5, or just pi over 5. Okay, again, all we're doing is we're multiplying by the conversion factor. Pi radians is 180 degrees. Okay, which is the same thing as saying 180 degrees is pi radians. Canceling. And then just using fraction simplification. Sometimes, if you're lucky, you can get it in one guess or two guesses. Sometimes it takes more. And every time we cross it out, that's just part of simplifying. So this one, I see they've got a 5 in them. So I do 325 over 5. Okay. And 325 over 5 is 65. Okay. And then I do 180 over 5. And I get 36. All right. Now, see, can I go any further? I don't know that I can. 65 and 36. Let's see. Sure don't have a 9 in them. Do I have a 2 in them? Do I have a 3 in them? 6. Yeah. We might honestly be done. So we have 65 pi over 36. And here's how you check your answer. If I want to see if I'm right, now remember, pi is 180, right? So I take 65, I multiply by 180, I divide by 36, and I get 325. So we know that that's right. Okay? So please make sure you understood what I did here. If not, rewind if needed. And then in a moment, I'll move on to the other way to convert, the other direction. All right, so converting from radians to degrees. We're now going the other way. So to convert from radians to degrees, remember here, what we need to remember is actually up top, we want to use pi over 180. Okay, we want to use that because that cancels out the degrees. Here, we want to cancel out the radians. Now notice that this pi and this pi will cancel. It doesn't matter what pi is, right? If you multiply by pi and then you divide by it, as with any number, it's like nothing happened. If I multiply by 3, then I divide by 3, I'm back where I started. If I multiply by 10 and then divide by 10, I'm back where I started. If I multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm back where I started. Okay? So the idea here is, if I'm converting 2 degrees, I want the pi to be gone. That pi has got to go away. Pi has got to be canceled out. Okay? So now what I do is I just simplify. So 180 is divisible by 4, and it's 45. and then I do 3 times 45, and I get 135. And remember, these are degrees. Okay? Showing you this one, again, the idea is 180 over pi. So the pi's will cancel. Okay, this one's going to be similar. We get the similar cancellation, 1 and 35. Rather 45. And then we do 45 times 7, and I get 315 degrees. Okay, so all you're doing is you're multiplying by 180 over pi. The pi's are canceling, and you're simplifying from there. Okay, so please take a moment, pause the video, try the next two. The first one is just the same, but the answer is negative. And then when you're ready, unpause, and I'll show you what I got. All right, so on the first one, again, you're multiplying by 180 degrees over pi. Okay? And then this would be a 1, and this would be a 60. So this would be negative 60 degrees. If you think about it, pi over 3, a third of 180 is 60. And it's a negative, so it's negative 60. 11 pi over 3, same idea, 180 over pi. Pi's cancel. So it becomes a 1. So it becomes a 60. So this is 660 degrees. Okay? So again, it's just converting back and forth between radians and degrees. And just remembering that one way to think about it is in degrees, there's not going to be a pi in them, whereas radians, there will be a pi in them generally. Okay? So if I'm asking you to convert from radians, you're looking for something that probably has pi in it. And if I'm asking you to go 2 degrees, then the pi needs to be gone when you report your final answer. Okay, going to our last problem. So here's how I want to summarize this up. So now Gabby and Jackie, 2 other sisters, enter my magical masterpieces. And then now they set their eyes on 2 other pies. So Gabby cuts a slice of the child-sized pie, again 3-inch radius, and it forms a central angle of 5 pi over 6. Jackie cuts a piece of adult-sized pie that forms an angle of 11 pi over 30. Who gets more pie and who pays more money? Who gets more pie and who pays more money? So first, what I want you to do is this. I want you to think about if you were to draw this. Let's see if we can draw this. 5 pi over 6. Well, pi is 180 degrees. So this is almost 180, but not really. It's 5/6 of that. So this is Gabby's slice. And now Jackie cuts a slice that's 11 pi over 30. And 11 pi over 30, well, that's about 33 would be, 11 over 33 would be a third. So it's a little bit less than a third of pi. So think about what we just did and turn back to the Avery and Hadley example if you need to. Thinking about the fact that this is a 3-incher, this is 3 inches, this is a 6-incher, 6 inches. Thinking about what we did with the degrees, how do you think I could use the fact that this angle is 5 pi over 6 versus the total angle of 2 pi for a circle, and this angle here is 11 pi over 30 versus the total of 2 pi. So what I want you to do, pause the video, try to solve this similar to how we did the Hadley and Avery example, and then when you're ready, unpause, and I'll show you this one last answer. All right, so it's a similar idea, right? So usually we would take the degrees that we had and divide by 360. So here we're doing the same thing. We're taking the degrees that we had and dividing by the radian version of 360, which is 2 pi. And so that's the same as doing 5 pi over 6 times 1 over 2 pi. So it's 5/12 of the total area. or the total circumference and the total area. So now we know the total area, remembering the total area as is was 9 pi and the total circumference was 6 pi. That didn't change. The total area here is 36 pi and the total circumference is 12 pi. Okay? And that's inches squared, inches squared, inches. That didn't change. The radius didn't change. Okay? So now what I'm going to do is, now that I know this, I'm going to now come over here and I'm going to do 5/6, or rather 5/12 times 9 pi. Okay? And what that gets me is, that gets me 3.75 pi. So just like how you take the ratio and multiply it with degrees, you can do the same with radians. So now I'm going to do the length, 5/12 times 6 pi. And I get 2.5 pi. Okay, over here we're going to get the same thing, or a similar thing. So 11 pi over 30 times 1 over 2 pi, right? Because to divide by 2 pi is to multiply by 1 over 2 pi. So it's 11 over 60 is my magic number. So here I do 11/60 times 36 pi. And I get 6.6 pi inches squared, right? Remember, this is inches squared in inches. And then I get the length, and that's 11/60 times 12 pi. And that would be 2.2 pi inches. So what happens again? Jackie gets a lot more pi. She gets 6.6 pi inches squared, and she also ends up paying less money. Gabby pays a little bit more money because her crust is slightly longer. But this is the idea. Okay? With degrees, you take your measurement, you divide it by 360, you times it by either the area or the circumference. The area gets you the area of the sector, and this gives you the length of the arc. Okay, radians, it's going to be the exact same thing. You take your measurement and you divide instead by 2 pi, okay, and then you multiply that by the area to get the area of the sector, and the circumference to get the length of the arc. Now, hopefully you've seen these two are exactly the same except for the 360 versus the 2 pi. And that's the beautiful thing about how radians work. And now that you know about the pi stuff, you can actually go on your graphing calculator, hit mode, change to radians, and every time you want to do pi in your calculations, right? For example, if you want to do the sine, so you could hit sine, you could do second and then pi, and pi, that button is right above the division sign, and you could do sine of pi over 3, and it's the same thing in radian mode as doing sine of 30, or rather sine of 60 in degree mode. So there's a lot of this nice overlap that you can use. All right, so to summarize it up, in a circle, you can solve arc length and sector area problems with radians in much the same way you do with degrees. How do you find these two things? You take the angle, you take the central angle, and you divide by 2 pi. You multiply by the total area to get sector area. okay? Or you multiply by total circumference to get the arc length. Okay, so hopefully you found this to be helpful. It is important that we do begin to discuss radians, and going forward, I will be assigning some problems to practice. Please make sure you go ahead and take a look at the debrief for today's lesson to make sure you understand where you're doing well and where you're struggling. And then going forward with my HRW, I may begin to assign you problems with radians in them. Okay, but obviously I wanted you to understand where they're coming from before you just suddenly start to see problems and you have no idea what they're even asking you. All right, so folks, keep it up. Thanks much for watching. Send any questions. I'm looking forward to a great hangout on Wednesday. And until next time, have a great one.